Hey guys, welcome back to my channel. So in this video, I will explain how to make a lithium-ion battery pack for electric vehicle. So guys, before going to make a battery pack, you have to learn some knowledge about series and parallel connection. What is series and what is parallel connection? So let's get started. So guys, today's topic is EV battery, lithium-ion battery pack. Guys, this is lithium-ion cell 18650. This is a 3.7 volt and a 2600 mAh battery. So using this type of battery, this is a single battery. Using this multiple battery, we used to make a battery pack. Okay, 3.7 volt. See guys, in 18650, in lithium-ion cell, this will be constant. Volt will be constant. Start from 3.7 volt to 4.2 volt. 4.2 volt, and but it's vary from 1200 mAh, 3000 mAh, 5000 mAh. Based on this capacity, this cell capacity, we can make a battery pack. Okay. So guys, I'm going to show you the guys. Here I have a 2600 mAh cell, so I'm going to all about we are consider our battery pack. We have using a cell of 2600 mAh. If I have a 4000 mAh, then I will show you that, but I don't have now. I have 2600, so just consider our entire section will be based on talk about 2600 mAh battery. Okay, so this is a cell. This is a 18650 lithium ion cell. These batteries are widely used in electric vehicles, and not only in electric vehicles, in all the electric appliances like mobile phones, and also kids car, and also the emergency light, backup light, solar light, etc. So let's talk about kids car. Okay, for kids car, there will be a 6 volt, and ampere will be like start from 5 amp to 10 amp. So I will consider 5 amp. So for kids car, kids bike, and for electric cycle, start from 24 volt, like 10 ampere, 30 ampere, 36 volt. In India, we use 36 volt hub motor. This is widely we use 36 volt, 10 amp, 30 amp, etc. Not only 10, 30, we can also use like 7 volt, 7 amp, 5 amp, 12 amp, etc. And for EV vehicle, I mean scooter, start from 48 volt, 48 volt and 30 amp, 60 volt, 72 volt. So guys, for kids car, kids bike, we widely use 6 volt, 5 amp, and also 12 volt, 12 volt, 7 amp. So based on the customer, we used to make this battery pack. In our company, we used to make this type of battery pack based on our customer requirement. So here electric cycle, for electric cycle 24 volt, 10 amp, and and also as well as 30 amp. And for this is for PMDC side motor kit. For hub motor kit, there will be a 36 volt, 10 amp, and 30 amp. This will be. If you increase the ampere, then your mileage will increase. Because if you are using a 36 volt motor, then you have to use a 36 volt battery. Ampere you can increase according to your controller. And also electric vehicle scooters, like a 48 volt 30 ampere, this will be a basic one. So for non-registration model there will be a 48 volt, and for 30 ampere your mileage will be around like you will get 50 to 60. That calculation I will explain you, teach you in later on section. And next following by like 60 volt 72 volt, maximum 72 volt in scooter. Okay, as for now, please just observe this one. So let's check kids car. For kids car, how to make a battery pack for kids car, kids bike. Okay, 6 volt 5 amp. This one will see now. Okay guys, now I will teach you series and parallel. In series there will be a sum of voltage, and in parallel there will be a sum of ampere. So ampere is nothing but current. So here, if in series, if our voltage will be increased, means ampere will be constant. So here constant ampere. In parallel, sum of ampere will be add up, but voltage will be remain constant. So guys, this is very important for making a battery pack. This steps is very important. This series and parallel. So if you have a strong knowledge in series and parallel, then you can make any type of battery pack. Like 3 volt, start from 3 volt to 96 volt, yeah, hundred thousands of volts you can make yourself. So for that you have to learn series and parallel. You have to be strong knowledge, strong foundation in series and parallel. So again I will teach you. In series there will be a sum of voltage and ampere will be constant. In parallel there will be a sum of ampere or current, constant voltage. There will be a voltage will be constant. So let's show you the series connection. First I will show you the series connection. So guys, in series connection, sum of volt, okay, and constant current. So I have a battery. I have a two batteries, guys. I have a two battery, two cells. Okay, this is 3.7 volt, both 3.7 volt and 2600 mAh. Okay guys, I have a two cells. Each cell has 3.7 volt and 2600. Positive, positive, and here is the negative and negative. Guys, in series connection we have to connect. This is our first cell, so I will mention this is our first cell. This is our second cell. Okay, we have a two cells. This is a first cell and this is a second cell. We have to connect positive end of our first cell with negative end of our second cell. Okay, so what will happen here means our here will be a sum of voltage. So each cell has 3.7 volt. Got it? So 3.7 volt. If you have a 3.7 volt, then so guys, in series connection here sum of voltage. So we have a 3.7 volt, two batteries. So we connected in series. So here we will get 7.4 volt. Okay, 7.4 volt here, and constant ampere. Ampere will be constant. So ampere will be 2600 mAh. So we got a battery pack of here 7.4 volt and 2600 mAh. So this is a series connection, guys. So again I will explain you. So in series connection there will be a sum of voltage and current will be remain constant. So this is our first cell. Each cell has 3.7 volt 2600 mAh. So I am connecting first cell positive terminal with second cell negative. So balance first cell negative, we are considering this negative as our negative output, and second cell positive will be our positive terminal output. So in output will get 7.4 volt. So we can consider this as a 6 volt battery pack. 6 volt battery pack. So guys, series connection is over. Now we'll go for parallel connection. Parallel, sum of ampere and here constant voltage. Okay, I will explain you. So again, I have a two cell. Consider we have a two lithium-ion cell. Each cell has 3.7 volt. Both 3.7 volt, 2600 mAh. Okay, again positive, positive, negative, negative. So guys, this is a important step here. Just check here. So I'm connecting here directly. This is our first cell and this is our second cell. So I'm connecting positive terminal of our first cell with second cell. Okay, again negative terminal of our first cell with second cell. So now our connection is not closed. This is open. Connection is open because positive and positive, negative and negative. So now it's open. And I'm considering from here second cell positive is our positive terminal, output terminal, and second cell negative terminal is our negative terminal. Okay. So here what happened means here sum of ampere voltage remain constant. So here we'll got output of 3.7 volt. Ampere will be add up. Okay, 2600 into 2. So we got here 5200 mAh. We can also consider this as 5.2 amp. We can also consider this as a 5.2 amp, 3.7 volt and 5.2 amp. So guys, this is a parallel connection. In parallel connection, first cell battery we have to connect with the second cell battery positive, again negative with negative. So we have to take, we can also take our terminal from here. No problem, you can also take either this way, otherwise this way. Both are same. So got it? So this is a basic one, parallel. And so guys, till now we have seen only series and parallel, separate. Now we'll combine together and I will show you the series and parallel. What if series and parallel are in same battery or in same combined battery pack? So let's. So guys, series and parallel are together. Okay, our each cell value is 3.7 volt, 2600 mAh. Okay, so I want a battery pack of 6 volt and 5 amp. This is my customer requirement. Consider this is my customer requirement is 6 volt and 5 amp. So how I will make a battery pack here? So for that, here we have to use a series, and for this we have to use parallel. So we have to use both series and parallel, then only we will get 6 volt and 5 ampere for this 3.7 volt and 2600 mAh battery pack. So first we have to make a parallel connection. This is our first step. Okay, step 1, parallel. So I'm leaving this section here. So I will explain you step by step. Okay. So for first step 1, I have to make a 5 amp. So for 5 amp, 2600. So I'm going to use here parallel connection here. So each cell is 2600 and 3.7 volt. Positive, positive, again negative, negative. So guys, here we got 3.7 volt and 5200 mAh. Got it? So okay, and again I have to make, again with two cells I have to make. So take next set of battery. So total we are going to use 4 battery. Okay, 2 cells and again 2 cells. Again we have to follow the same procedure here. So again 3.7 volts and 5200 mAh. So guys, okay, guys, see this carefully. I'm using a 4 battery. First set 2 batteries. Okay, each battery I connected in parallel and I got 3.7 volt and 5200 mAh. Again I'm using a 2 batteries, 3.7 volt and 5200 mAh. I got it. So till no parallel connection has over. Now we have to connect this as a series one. This is our output, right? So now consider this is our first. Consider this is whole thing our first cell and this whole thing our second cell. Okay, this is our second cell. So connect. So guys, connect our first cell. First cell. That means these two cells output negative with second cell negative, second cell positive. Got it? And now here you will get here output of positive, and this will be our negative. So here what happened is our sum of voltage. So 3.7 volt, 3.7 volt will get added. So 6 volt. I mean 7.4 volt. So 7.4 volt and ampere will remain same. So ampere is 5200 mAh. So guys, is clear now? I will explain you again. So for this first step, we have to take a 2 batteries and connect together with parallel connection and take one common terminal. This is our common. Okay, this is our common one. And again take next set of again 2 cells and connect again parallel connection. And from these two set take consider this is our single set of battery. This is our single set of battery and this is a single set of battery. This battery pack has 3.7 volt and 5200 and this has 3.7 volt and 5200 mAh. Now connect these both batteries together and make a series connection. So for series connection, connect first battery negative terminal with second battery positive terminal. So you will get first battery positive terminal, that will be our output terminal, and second battery negative terminal will be our negative output terminal. So here we'll got 7.4 volt 5000 mAh. Okay guys. Now I will explain these things in more clearly. See guys, in real world, how you will make me consider this is a battery, okay, and again positive, positive. So guys, connect this positive. So connect all the positive together and again negative together and bring here. Okay. Now connect our negative terminal of our first state with second positive connection. So here what happen means, here this will become our negative output, this will become our positive output terminal. Okay, so we'll got 6 volt and 5 ampere. So guys, I hope you like this video and you learned some series and parallel connection. So in next video I will come up with new topic. Thank you. Bye bye.